Alright, hi guys, welcome to Dimensions Woodworks. Today we're going to do a project today that's a little bit different. I debated for a little while on whether or not to actually post this video to the channel, simply because it's not a woodworking related project, although it is a DIY project and it was built right here in the Dimensions Woodwork shop. So a little backstory, a few months back, my brother-in-law is a big race promoter. He promotes a large diesel race here in the South every year. So as part of his big diesel races over the last few years, he's always done a side event for Tug O War and burnout competition. So those events had gotten so large unto themselves that he started doing Friday night tugs and just doing Tug O War throughout the race season leading up to the large race, the fall finale in November here in South Mississippi. And for this year, he was like, called me up, he said, hey man, here's a cool idea. What if we take all our kids, you know, most of us have children. We take all the kids and we put them in a Power Wheel and we let them do tug of war against each other. I was on board. I thought that was a great idea. So we went out there the very first time with no modifications whatsoever to the Power Wheel. And I have all girls. I have 4 little girls. So 2 of my little girls were in the Power Wheel and they won first place. From there, they kind of caught the bug. They kept getting more and more into it. And then, you know, of course, so did Daddy. So I modified this thing heavily. So this is the process of the build for this modified Power Wheel. It does go through everything from stripping it all the way down to the frame, the paint, and the materials that I used to restore it. It was a little sun faded when we started. Then all the modifications to the motors. I put a variable speed throttle in there. And then I also put electronic scooter controller, which allowed us to get that variable speed throttle and to have some other capabilities as well. I do go very in depth toward the last 3/4 of the video on how to wire this thing effectively and to be able to keep as many stock components in line as you can. I think that was the biggest challenge for me with this because there are 3 gears basically on the Power Wheel, and to make them all function the way that they should so that they could use it to play with while we're not out there doing tug of war. There are a few videos at the end, little clips at the end there where we did several competitions, and the ones you'll see are the championship rounds from each tug of war. I hope you guys enjoy. Thanks a lot. Like, subscribe, and check out some more of my Dimensions Woodworks videos right there. First, okay? Alright, so our project we have going now is Bella and Bailey and Mackenzie are in the shop trying to help me today. We are taking their Jeep Wrangler Power Wheel and we're basically stripping it down. All I've done right now is strip it down to the frame. We've got all the wires out. We've taken the major components apart, so we just have a basic frame right now, and what we're going to do is go ahead and sand it. Okay, so we want to get everything sanded down really well. Say hey girls. Hi. We're making a super Power Wheels for these guys because Bailey and Bella have been doing tug of war with their Power Wheels, and it's starting to turn into a pretty big event down here. So we want to hot rod their Power Wheel and get it ready to go. So I want to take you guys through a few steps of the way just to see what I'm doing for my girl's Power Wheel and let you see what it looks like when it's done. Okay, so what we've done so far to help reinforce, because we're doing tug of war, is we only have this little hole in this plastic bumper here. So I wanted a little more strength there. So I took a piece of wood and I mitered the edges to a particular angle so that I could come back to the main body and brace to the bumper. Okay, so then I took a little piece of scrap, stainless steel that I had around the shop. I kind of hollowed out a hole, and I don't really have many metalworking tools, so I did the best I could. And I'm going to place that, affix it to this piece of wood, and it hasn't lined up quite just right yet, but that's going to go over the hole, so whenever they're pulling force in this direction against it, doing the tug of war, it'll have that metal there to support the rope tied to it. So we're going to amp this thing up. It's going to have a whole lot more torque and quite a bit more power when it's all said and done. So we want to be prepared for that and not rip the bumper off. Girls, are y'all excited to work on your Power Wheels?
Yeah.
Alright, so I broke everything down and lightly scuffed it up. So we're going to shoot it with a few coats of primer. I decided to go with this 123, who makes this? Zenisser, whatever that is. 123 primer, because it sticks to all materials. So I've never painted anything plastic before. This is a first, so we're going to try that multi-purpose primer. Alright, so we're going to go ahead and start putting on the first coats of primer and let it dry really well so it can adhere. The paint can stick to this plastic really good. We got it all primed up on the bottom side. I want to let everything dry really well. Probably overnight since the sun's kind of going down. But everything's got its first initial coat of prime. Everything's nice and white. Alright, so after we got everything primed up white, spot sanded in the few little areas where we had problems. I re-primed those areas. And now we're beginning to lay color down. Alright, we got the first coat of blue down. I think it looks pretty good. Still wet, but I think it laid down alright. We just got to see how durable it is whenever we contend with issues where they bump into something and it starts scratching. We have everything connected in line. Now that our paint's drying outside, I want to bench test some of the components because, you know, it's nice to make it look pretty, but if we press the gas and it doesn't go, then we've defeated the purpose. So here is, with the ESC in line, 24 volt setup, the stock Power Wheels motor and gearbox. So that's about the stock speed. And that's the speed that we're able to get just adding the ESC and the throttle. What we're doing now is to just, while the paint's drying, trying to fit up our new Traxxas 775 motors to our old gearboxes, since obviously you just saw the bench test and these 775s are much more powerful motors than the old 550s, okay? So we just really want to line up and give a good indication of how the teeth are going to engage from this pinion gear on the motor to the gear into the gearbox. Alright, so you see that there, right? Well, what I did was I went ahead and bought one of these rubber grommets because from Fisher-Price, they have something similar to this, but of course this motor is not the same size as this stock motor, so we have to make a few modifications in order for those teeth to fit, the motor to fit properly, and for it to seat as it should so that all the gears engage properly and then the thing, we get its full potential out of it. So I went to a hardware store. I believe I got these at Lowe's. I buy a lot of stuff there. Just a rubber grommet. Let's see if you can pick all that information up on the camera. 3/16 I believe. It's a 3/16 outside diameter, 1/2 inch inside diameter. And I've put it on the motor beneath putting the pinion gear on, then inserted the pinion gear and its keeper key right there at that little Allen head. So that puts me to where I still don't have great tooth contact. You can see kind of how high, it's kind of hard to get the ratios of that, how high that gear is riding, and I would prefer for it to ride a little lower, more in the middle. Okay. So here we're going to show you, now I've marked one of the prongs on the gear with black so you can see the relation of how fast it spins. This is the same setup on both of them, same battery setup. So all I'm going to do is show you the stock 550 Fisher-Price motor. And that's about stock speed. Okay, and that's wide open. Now granted, we did put 24 volts to this. That variable speed throttle does help out a lot because it's not jolting the system straight from nothing to full blast. This is with the XXX 775 motors that are available, which is what is pictured there. That's what one of these guys look like. So, I mean, you can just see side-by-side comparison there that obviously the XXX is going to give you a little more power than this little Fisher-Price 550 motor. Here's the test run with the XXX motor. Same setup. And you can see it's definitely faster than that 550 motor. I think also a big part of the problem here is that you can hear that gearbox grinding in there, and what I want to do is get in there and clean all that out really well, soak it out, remove all the old grease, and then completely re-lubricate everything with typical automotive fitting grease, and get in there really well, and it'll take that graininess out just from dirt getting in the gearbox over the years. But everything's working out pretty good. All I have in line right now is the ESC control module and on-off switch and the motor from the battery. So I wanted to make sure I bench tested everything that it worked properly. When I first got this in, actually, I thought they had sent me a faulty module because the wiring diagram these guys sent me from this particular seller on Amazon. Let's see if you can see it right there. It says red and blue connector power locks. Well, what they actually meant by power locks was power lock or on-off switch. And I don't know, maybe you guys are better than I am, but I didn't get on-off switch from power lock. So I did not have a switch in line. When I thought it was faulty, I ordered a new one, had it shipped in. With that one, it was repackaged by an American seller, so it was obvious as soon as I got it. It's the same manufacturer, so I put a switch in line, boom, it worked. Also, in line from my hot lead, from my battery into my control box, I have a circuit breaker, which will be in line in the finished build. How many amps is that one? I think this one may be a big one. No, that's a 30 amp. This is a 40 amp, and I found a 50 amp as well because I thought that was my problem initially with the Fisher-Price batteries. The real problem with the Fisher-Price batteries was that Fisher-Price has a circuit breaker built into the battery itself, and it kept kicking out whenever it was under a load. So buying these aftermarket batteries has helped tremendously. So the stock Power Wheel comes with a 12 volt 9.5 amp hour battery. So I've run two 12 volt batteries in series, but these are 20 amp hour batteries. So not only am I getting a lot more power, but it's going to endure over a lot longer time frame. Okay, so I took it apart. We got all the old grease out. They're all cleaned up. So now it's going to be time to re-grease and situate all these back inside of the housing. Okay, so I Went out to Lowe's and picked up one of these tri-packs. It's got extra heavy duty, red and tacky, and another extra heavy duty. So we're going to see which one of the greases here are going to work best for this application. I think it may be the red and tacky, but I'm just going to open them up and check out the viscosity on them. Because we do want it to stick, we don't really want it to sling out whenever it's applied. Alright, so I got it all greased up, gears back in there, reassembled. Right? I want to mount my motors. For these particular motors, these Titan 775s, I used a M4 by 0.7 by 35 metric screw. Okay, so and I've seen this on a lot of posts and forums. I have no idea why Power Wheels goes ahead. Fisher-Price manufactures it with the holes for the 775 motors, even though they do not sell a 775 motor. Go figure. Maybe they're being nice because they know that their motors are too slow from the factory. So what we want to do is use those 775 screw holes. I think we're good, we're tight. Okay, so now once we got all this stuff taken care of, motors are installed, gearboxes are cleaned out, greased, and reassembled, we're going to do another bench test on it and see how she does. So, I don't know if you guys remember the speed that this thing was spinning before, but here goes the bench test. Okay, so I just basically took a little thin sheet of underlayment plywood because it mirrored what we had here with the stock pedal. So now that we have a variable speed throttle, it will need to go below where the pedal mount was, and I didn't really want to take the time to try to have to deal with that. So I just laid this upside down on that piece of plywood, traced it out so that it fits, and then had to cut out, for my particular pedal, what would make it work in this application. Drilled some holes in the extremities so that it can screw down and the pedal can be mounted there. So also, while we were doing that, the system, the ESC for this module needs an on-off switch, so we went ahead and mounted an on-off switch, like a racing style on-off switch. Another thing I wanted to add into the system was there's a voltage meter here, so it's actually going to act as your gas gauge, essentially for the system, to give you a readout of how much voltage is left going through the system. So when you get to the point where it needs to be recharged, you'll know that without just running the batteries down until they die. So we got a little bit of wiring to do now. We've hit a little speed bump, and I have to take a little bit of time to figure out the wiring schematic that we're going to have to use to make this work. Each of our motors are installed with the gearboxes. All that came in with putting the rear wheels on. But we do have our gear shifter still to contend with, and it is mounted right here. So in this stock from Fisher-Price, you have a low, a high, and then a reverse gear, which are actuated by these relays. Okay, so since we've changed the way that this machine is wired, because we've put the ESC in line, I think we're going to go ahead and probably just mount the ESC against the back wall here in a convenient place so we can wire relatively easily you have a feed in from the battery with the circuit breaker in the middle, and then you're going to have power out to the motor, and then power out to your other accessories that you need to use, as well as your throttle cable. Now it looks like the Jeep that it did look like before we took it all apart to clean it up and paint it. I think we definitely have made some vast improvements. This paint is holding up relatively well. I used an exterior house paint, so we have everything back together pretty much. Now we just got to get into the wiring and make this thing go. Okay, so let's do a little overview of the wiring. Now, you want the batteries running to series, so I used the red lead for the positive. I used the blue lead for the jumper to jump the two wires together. So the blue wire comes back to the positive. So the blue wire is connected to the negative in the front and the positive battery on the second battery. Then the negative lead comes out into what feeds the power in to the ESC. The positive wire connected to the front battery runs down through the channel, past the gas pedal, out to the fuse block. So we did put a fuse in line. When I looked it up, these motors draw about 18.4, 18.6 a piece. So we used a 40 amp self-resetting fuse breaker, circuit breaker rather, so that if it blew a fuse, it didn't just blow and then you're dead in the water. Come back to the in line of the ESC, which is black and red. Okay, so where it got tricky is out. So the motor out from the ESC is blue and yellow. This particular ESC, which is pretty common and the one I saw the most of, the yellow is negative and the blue is positive, so I jumped into that, blue and positive. Okay, so tracing out where all of these wires led once they come through, I had misspoke earlier in the video and refer to these as relays. These actually are not relays, it's just two switches. Now I cannot take any credit whatsoever for figuring out the wiring to this. My stepfather, Dwayne, helped me out with this, because without him I would have never figured out where all these leads went. So it did get a little confusing, because the way they have it wired, whenever the motor is in high, then, or rather the shifter is set to high, then the motors are run in parallel. When it is in reverse and when it is in low gear, they run in series. So all we want now is for, it doesn't matter if this is in high or low, it's going to go forward, because now we have the variable speed throttle. We just want reverse to switch polarity and reverse the flow of positive to negative, so that the motors spin in the opposite direction to give you a reverse gear. Okay, so it's going to be different on every one of these guys, and basically what he did is sit down and map out with a voltmeter across the connectivity from the positive negative in, and see with that voltmeter what each one fed and in each gear. So this is not going to help everyone, but it will definitely help you if you have this same setup and these same color wires. So out of the ESC, yellow is negative, blue is positive. Okay, so you feed into red and black going in, which were the wires that originally connected through the gas pedal, and then there was also an orange wire that went across the gas pedal. Okay, the orange wire is now no longer in use. You do not need it anymore. You just need red and black feeding the switches. Okay, so
after mapping all that stuff out, the only ones you need to come out of is your orange and red wires here. You do not need. Those originally went out to the motors as well, okay? You just need the wires that originally went out to the motors were red and black and orange and blue. You only need blue and black coming out, okay? So off of your blue lead, you come back to your motor. Now, this is going to vary as well if you use a different motor. Out of your blue wire, you come out to negative on this, I guess it's hard to say, on the passenger side, and then positive on the driver's side. Okay, out of your black wire, you come out to positive on your passenger side, and negative on your driver's side. Okay, so I know this is kind of jumbled up and it's a bit wonky looking, but before I got it all cleaned up and tie strapped in and tightened up, I wanted you guys to be able to see that. Okay, so we'll go over this real fast. Your on-off switch, I tied into the positive side coming out of our voltmeter so that the voltmeter only illuminates and comes on when the switch is turned on. Okay, so now we have our quote-unquote gas gauge. We're reading 26 volts, which is perfect because we're fully charged right now. Okay, so I kept the negative running straight back to the battery. There's one of the negative leads. So one of those goes out to the ESC, one goes to that voltmeter so that we can tell how much juice we have. The positive side is tapped into the on-off switch here. So it only illuminates when the switch is turned on and you're ready for use, okay? We're in high gear right now, and we're going to hit it. Okay, spinning forward. And spinning forward. Okay, so low is the same. And then reverse. Spinning backwards. Spinning backwards. So, guys, you don't know how long that took to map all that crap out. And I'm very indebted and grateful to my stepfather, because without him, it would have taken me forever if I ever did figure out how it was supposed to be wired correctly. So, big ups to him. Without him, I would still probably be working on this thing. So, let's look at it wide open. We're gonna now, also another note is this thing goes just as fast in reverse now as it does in forward, so you can go either direction. And let's hit it. It's a pretty fast Power Wheel.
2, 1. Go, baby. Don't make the noise over the Power. Three, two, one.
Go!
3, 2, 1. Go.
See, we're going, but we just stopped.
Shake! You gotta rock, Kenzie.
3, 2, 1. All right.
Here we go. Who's out with the little police officer goes to burn out on the far side? Who's out with the green black truck over here on the left? All right. We'll see what happens. Hey, don't let them look fool you now.